All right, so the recording has begun. This is day 3, week 4 of our journey together. And hello, good afternoon. And it is so glad, I'm so glad to see each and every one of you here. Still have some more persons to come, but it's after 6, so we have to move. So I'm going to share my screen with you all. Okay,
Good evening.
Hey, good evening, Deshaun. Dylan is still not feeling good.
Well, you come to class now.
Okay, that's good.
You good now.
All right, that's good. Glad to hear that. All right, so last class we looked at section 3, that was dealing with factorization of those algebraic expressions. Today we're going to be looking at some laws, some important laws that essentially help mathematics to be mathematics. So head up with me. Today is Wednesday, the 27th of July. 2022. So please take good, diligent notes, and you know that after class, please send the notes for me. Make sure that you take down all the notes, and once class is over, you send them to me before you go to bed. Please do not take forever to send the class notes. Okay, so the topic today is, for this section, we're going to be looking at the commutative law or property. So the commutative property. So I could say essential properties. So that's let me change it to essential properties. Let's say essential mathematical properties. Sorry for those who are writing. Essential mathematical properties, and section 1 is going to be on the commutative property. The commutative property. For those, all right, so section number 1, the commutative property. Okay, so anyone is familiar with the commutative property? Anyone?
No.
No? Okay. Okay. All right, so today we're going to be looking at that property. It's not hard, and you may not know it by name, but I'm sure you're familiar with it in practice. So the commutative property let's start off with what the word commute means. So the word commute means to, if we say commute, what does that mean? Anyone know what commute means? Like if I say I commute from home to school, what we would mean by commute.
You go from place to place.
Yeah, we go from place to place, or we could say we travel, right? So commute means to travel from one place to another.
To another.
Yeah, that's what we mean by commute. Rashan, where's your sister? She's to work again?
Yes, sir.
Okay. All right. The commutative property of mathematics. Sorry, in mathematics, we should say. In mathematics, commutative property states that the way we add or multiply does not matter because the result is always the same, no matter what. More specifically, it states that that if we switch or commute the numbers around, we will still get the same answer. So the commutative property of in mathematics, the commutative property tells us that the way we multiply or add does not matter. We still get the same answer no matter what. When we are multiplying or adding, the way we do it, it doesn't matter. The answer will still be the same. So we could commute the numbers around, we can switch them around, we can travel them around, and we still get the same answer. All right. So for example, well, let's continue. So in general, symbolically, we can write this rule or this property in the following way. So let's start off with the commutative property for addition. So it's gonna say if we have A plus B, that's gonna be equal to B plus A. And that right there is what we call the commutative property of addition. So AB, sorry. Okay, so let me keep that up. So A plus B is the same thing as B plus A, right? That's the commutative property of addition. So it says that if we switch them around, it doesn't matter, it'd still be the same. So that means that A plus B is the same thing as B plus A. I think it'd probably be better if I write it like this. It'll look better like this. Good. And then the commutative property of multiplication is sort of the same thing, just different symbols. So commutative property of multiplication tells us that A multiplied by B, right? So A multiplied by B is the same thing as B. So A multiplied by B is the same thing as B multiplied by A. So the first one is the commutative property of addition. The second one is the commutative property of multiplication. So A plus B is the same thing as B plus A. All right, so for example, if we say, so the instructions is, in each case, apply the commutative property, simplify your answer. So in each case, we want to apply the commutative property, and we're going to simplify our answer. So for example, if I say 3 plus 4, remember the commutative property says that the way or the order in which I add doesn't matter. So it'll end up being 4 plus 3. And Ciara, what is 4 plus 3?
7.
7. Very good. All right, so the next one, we can have 2 plus 6. And if we would apply the commutative property to this, Albernique, what would we do?
It'll be 6 plus 3. 6
6.
plus 2.
Very good. 6 plus 2. And what is 6 plus 2, Albernique?
8.
8. Very good. Now if we were to do it for multiplication, so we'd have something like 5 multiplied by 6. And Rashan, what would we do?
Times 5
Very good. So it's going to be 6.
equal 30.
Very good. 6 times 5. 6 times 5, which gives us 30. Very good. So that's the commutative property for multiplication. Now for let's try another one for multiplication. So let's say we have 7 times 2. Dylan, apply the commutative property to that. What would it be?
It will be equal to 2 times 7.
Say it again. 2 times 7. Very good.
Yep.
What is 2 times 7?
14.
14. Very good. Now, it doesn't have to only be numbers. It could be letters too. So we could have it for letters. So let's say we have x plus x plus y. Tell me, Jasmine, apply the commutative property to that. What would it be?
Y plus X.
Y plus x. Very good. Can we simplify that further?
No, sir.
No. All right. We could also do it for letters for multiplication as well. So if we have h times m, alternate, what would it be? H times m. Apply the commutative property to that.
It will be m times h.
M times h. Very good. M times h. Sierra.
Yes, sir.
What time does class start?
6 o'clock.
Okay. So just a gentle reminder, class starts at 6 o'clock, not 6:20, not 6:30, not 6:15, not 6:04. Please don't come to my class late because then you're gonna be lost. All right. So make sure I come to class on time. The lateness is unacceptable. All right. So make sure I come to class on time. All right. So okay. So we know what the commutative property states, and we know how to apply it. We know it works for addition, and we know it works for multiplication. 3 plus 4 is the same thing as 4 plus 3. We could switch them. So like I said before, the commutative property states that the way or the order, it's a very important term, if we could put that there, the order in which we add or multiply doesn't matter because the result is the same. Okay. Now, these are good examples. Now the question is, what about division and subtraction? So does the commutative property work for subtraction? What do you think, Deshaun? You think the commutative property works for subtraction?
I think so.
You think so? Okay, so
No, sir. I don't think so.
you don't think so? Okay, so Deja says no. Deshaun says yes. So let's try. So the question is, but I can't. I don't want to write that again. Is it true that the order or the way in which we subtract doesn't matter? Let's try, or let's determine if the commutative property holds, or say works. Well, holds is the same thing as works. But if that's determined if the commutative property holds for subtraction.
I have a question. Does signs matter for this property?
I know. You already said no, so
That's why I asked it. If it don't
I,
matter, then it would be yes.
well, we'll see. You already said no, man. You already boldly declared no, so I can't help you after that. All right, so is it true that the way in which so if the commutative property holds for subtraction, then that means that when we subtract two numbers in one order and then switch them, the result should be exactly the same. So if the commutative property works for subtraction, then that means that when we subtract two numbers in one particular order and then we switch it around, we should get the same thing. Because if you look at for addition, 3 plus 4 is the same thing as 4 plus 3. We still get 7. If you look at 2 plus 6, 2 plus 6 is the same thing as 6 plus 2. We get 8. So if the commutative property works for subtraction, then when we subtract two numbers one way, when we switch them, we should get the same thing both times. All right. So let's do this using an example. So let's see. So let's construct a table. So we can look at the first way. We can look at the second way. And the question is our result still the same? So the first way we're gonna look at, say, 7 minus 3. So 7 minus 3 is pretty straightforward. Jasmine, what is 7 minus 3?
4.
4, very good. 7 minus 3 is 4. So let's switch it. So if we switch it, we'll get 3 minus 7. And what is 3 minus 7, Sierra?
-4.
Negative 4. Okay, so does it work?
I mean, you get the same answer, but they're just different signs. So if the signs don't matter, then yes, it works.
Well, remember, look at the note, right? So the note says that if the commutative property, supposed to put property there. If the commutative property holds for subtraction, then that means that when we subtract the two numbers, the result should be what? Exactly the same.
The same.
So this one is 4, this one is negative 4. The result is not exactly the same. So the commutative property does not work for subtraction. We can try another example just to prove the point some more. So we call this a counter example. We can say 8 minus 5, or 8 minus, let's say 8 minus 6. 8 minus 6 is definitely 2. 6 minus 8 is, sorry, yeah, 6 minus 8 is -2. So definitely it does not work. We could also do it for, let's say we have -5 minus -2. That should give us what? -5 plus 2, which is what? -3. Hope you all follow that, because -5, negative and a negative times a negative is a positive. So -5 plus 2 is a -3. Okay. So that's what we get for this one. But let's do -2 minus -5. That's going to be equal to -3 plus 5. That's going to give us 3. So again, here we get -3, here we get 3. So it does not work. So the commutative property doesn't work for subtraction because we don't get exactly the same answer. Okay, don't get exactly the same.
Don't put -3.
Say it again.
So the second was we don't put -3.
No, because this is -2 plus 5. So -2 plus 5, it's as if you owe someone $2 and you have $5. So, okay, let me use a bad example. So this is what? +5, right? So +5, you could think of it like that. 1, 2, 3, 4, 5. So this is +5. So 5 of these are positive. And then you have -2. So this is negative. That's one negative. And this the next one is negative. So -2 plus 5. So the positive and the negative cancels. The positive and negative cancels. Oh, this is not 5. This is 1, 2, 3, 4, 5, 6. I need to put 5. So that's good. So we good now. So let's do it over. So if you look carefully, the positive and the negative cancels out. The positive and the negative cancels out. So we are left with what? 1, 2, 3. 3 positives. So it's +3. Okay. +3. So that's the idea there. All right, so that's how we get the +3. All right, so just be careful. So the commutative property works for addition and multiplication. It doesn't work for subtraction. The next question is, does it work for division? That's an open question. Anyone can answer it. Do you think the commutative property works for division?
So,
Think no? Okay. Why you say no?
I think yes. I don't know. I don't know.
You think yes. Okay. Jasmine says yes. She says she's not intimidated. It's a yes.
I think no.
You think no? Okay. All right, so Deja said she think no. And Jasmine says yes. So is it true that the way or the order in which we divide does not matter? So let's determine if the commutative property holds for subtraction. Now, if the commutative property holds for why I say subtraction? I mean division. Now, if the commutative property holds for division, then that means that when we divide two numbers in one order and then switch them, the result should be exactly the same.
So it works?
We're gonna see right now. We're gonna do an example and see. All right, so let's copy this table. So, but for this one, we're gonna let me move. Okay, interesting. You know, I don't think I should copy that. I should make a new one. So we're gonna look at the first way. Then we're gonna look at the second way. And then we're gonna check and see if the commutative property holds for those two ways. So first example, if we consider 8 divided by 4. What is 8 divided by 4? Al-Twanik. 8 divided by 4.
1.
No. Albert, can you help her? 8 divided by 4.
You called me?
Yeah. 8 divided by 4.
2.
2. Very good. So 8 divided by 4 is 2. Now, Mr. Deshaun, what is 4 divided by 8?
Is 2.
Deshaun, what is 4 divided by 8?
2.
4 divided by 8.
-2.
4 divided by 8. Deja, what is 4 divided by 8?
Half.
A half. Very good.
Oh, my bad.
Yeah. So 4 divided by 2 is 0.5, and we could prove that if we do long division, or we could just do it as a fraction and and bring in a lower term. So let me show you what I mean. So we're saying 8 divided by 4 divided by 8. So how much times 8 goes into 4? 0 times. Put the 0 down. 4 minus 0 is 4. Put the decimal point. So we could put the imaginary 0. So how much times 8 goes into 40? 5 times. So 40 minus 40 is 0. So here, when we do 8 divided by 4, we get, 2. When you do 4 divided by 8, we get 0.5. So does the commutative property works for this? Does it work?
Yes.
Yes. You sure? We get 2 and then we get 0.5.
Now we're not
No.
No, right? No, because we don't get the same answer. In order for the commutative property to work, we have to
Yeah,
get the
because the
same.
two of them are just different answer.
Yeah, different answer. Very good. So it does not work. Okay. Try another example. We can say 15 divided by 3. What is 15 divided by 3, Rashan?
5.
5.
5.
Very good. 5. 15 divided by 3 is 5. Sierra, what is 3 divided by 15?
That's 0.2.
Yeah, 1 over 5. 0.2. So 3 divided by 15 is 0.2, and so it doesn't work. All right, can someone give me an example of that one? Do you want us to try?
48 divided by 6.
48 divided by 6, which is 8, and 6 divided by 48,
0.125.
that's 1 over 8.
That doesn't work.
Yeah. So 0.125. So it does not work. So the commutative property here doesn't work. So the commutative property works for addition, subtraction. Sorry, the commutative property works for addition, multiplication, doesn't work for division, doesn't work for subtraction. So let's make a table. So if we were to summarize our findings, summary of, let's just say, which operations does the commutative property work for? So operation, commutative property. So if we have addition, it certainly does work for addition. So we could insert, there gotta be a tick somewhere here. So it does work for addition. That doesn't look right. So let me put yes. For multiplication, yes. For division, sorry, for subtraction, no. And for division, no. All right, good. So I think we're ready for practice. So that's the commutative property. It states that the way that we add or multiply, or the order in which we add or multiply, doesn't matter, because the result is always the same, no matter what. It doesn't work for subtraction, and it doesn't work for division. Because when we do it for subtraction, we find that once we do it the first way, it gives us a value. We do it the next way, it doesn't give us the same value. Same thing for division. We do it one way, it gives us a value. We do it another way, it does not give us the same value. So it doesn't work for for subtraction. And the same thing holds for division. We try to do it one way and we get a number, and then we try to do it another way and still getting a different number. So then that's an issue. All right, so let's go to practice. So we're going to do our first exercise. Say it again. All right, so the first question is going to be true or false. To commute means to arrive. True or false. The commutative property only works for multiplication. So it only works for addition, but never multiplication. For these one, you circle the true or false. So write the question now fully, and then circle the true or false. So if it's true, circle true. If it's false, circle false. True or false. The commutative property does not work for subtraction. True or false. When dividing by 0, the commutative property works for division. And the fifth one is true or false. A plus B equals B. plus A is the commutative property for addition. All right, so there is your questions. It's 5 of them. I'm going to give you 2 minutes to answer them, and then we'll be ready to go. And the timer has begun. To commute means to arrive. The commutative property only works for addition, but never multiplication. That's true or false. The commutative property does not hold for subtraction. True or false. True or false. When dividing by 0, the commutative property works for division. And finally, true or false, A plus B equals B plus A is the commutative property for addition. So please answer that to your best of your ability, and we'll be ready to go. Make sure to write down the questions as well. So don't just write true or false, answer the questions as well. Write down the questions as well. All right, that's time. All right, so we're gonna continue. All right, so let's answer these questions. Sorry. Okay. All right, so okay. Albanic, question number 1 is for you. To commute means to arrive. Is that true or false?
That is false.
That is false. Very good. To commute means to travel or to move from one place to another. The commutative property only works for addition, never multiplication. KC, is that true or false?
False.
False, okay. That's false because the commutative property works for multiplication as well. All right, Jasmine, the commutative property holds for subtraction. Sorry, the commutative property does not hold for subtraction. True or false?
True.
True, very good. Rashan, number 4. When dividing by 0, the commutative property works for division. Rashan. Let's go, Rashan. Number 4.
False.
Yes, that's false. Because the commutative property never works for division, even if you're dividing by 0. All right, number 5. Altonic. True or false? A plus B equals B plus A is the commutative property for addition.
True.
True. Excellent. True. All right. Any 5 out of 5, 4 out of 5?
Yes. 5 out of 5. 5 out of
5 out of
5.
5.
5.
5 out of 5.
All right. 5 out of 5. Excellent. Okay. That was the easy question. Glad that you all got it. It had a little spin to it, so I'm glad you all was able to see the little tricks there. So let's get into the main practice. So we want to, in each case, so let me keep this. So in each case, by the way, let me put this inside our notes so we could always have it. Bam. Excellent for those who got them right. Okay, so, and even for those who attempted, still good on your part. So let's do some more practice on this. So practice. In each case, apply the commutative property. If the commutative property cannot work, put not applicable. So NA. So it's not applicable. So in every case, apply this and simplify. So please simplify. If the commutative property cannot work for a particular question, then put not applicable. So let's look at number 1. So we're looking at 16 plus 5. What is that? 29 plus 12 equals we're looking at 18 divided by 6. What is that? 4. Eight times 7 equals, we're looking at 6 times 9. Sorry, not, these supposed to be multiplication, sorry. Multiplication and multiplication. So what if we have H plus R? What would that be? And then we have K multiplied by M. What is that? Okay. And then what if we have 17 minus 8? What does that equal? B divided by A. And the last one, N multiplied by 2 P squared. Alright, so in each case, apply the commutative property. If it cannot work, then if the commutative property can't work, then put not applicable. Alright, so we have 2 minutes to do that, and time has begun. Alright, that's time. So let's begin with the first one. Alright, go ahead. Algebraic 16 plus 5. What do we do for that? What do we do?
Okay, I got 5 plus 16 equals 21.
Good. 5 plus 16 equals 21. Algebraic 29 plus 12.
Okay, I got 12 plus 22.
12 plus 29,
Equals 34.
equals 34, equals 41.
That's 41.
Yeah, 41. Yeah, 41.
Put 22.
It's 12 plus 29, if you look carefully. 12 and 29. 9 plus 2, that's 11. And 2 plus 2 is 4, so it's 41. Who's next on the list? Sierra, 8 divided by 6.
Okay, so 18 divided by 6 is 3, and then it's 16 divided by 18, which is 0.33, and that's NA.
You wasn't supposed to touch it.
Oh, NA.
Okay, alright. So you don't need no working for that. I know he was trying to show it or prove it, but you don't need no working. So it's not applicable. We don't need to touch it. 8 times 7, Deja.
That's 56, and then when you do the opposite way, it's still 56.
So 7 times 8 is 56. And Deshaun, number 5.
Okay. 6. That'll be like 9 times 6 equals 34.
9 times 6 is what?
Uh, oh, 54. My bad. Sorry.
54.
I look at the wrong one.
I was saying, what? 34. 34, how?
That's my I mixed myself up.
Okay, number 6. Dylan.
So that'll be equal to R plus H.
R plus H, very good. And we can't simplify that no more. Jasmine, number 7.
M times K.
M times K, very good. KC, number 8.
NA.
NA, very good. Not applicable. Rashawn, number 9. NA, very good. Deja, number 10.
You would get 2p squared n, and then if you did 2p squared times n, you still get 2p squared n.
Okay, so what to put here?
2p to the second power n.
Okay, okay, that was wondering. Times n, very good.
Oh, you mean the opposite way? Never mind. 2p to the second power times n. Yeah.
Because you want to show the commutative rule. All right, so we switch it. If we were to simplify it further, we don't have to. But I did say simplify. I did say simplify. So
I simplify it.
so 2p squared n. All right, so that's it. Okay, 10 out of 10, 9 out of 10, 8 out of 10, and
10 out of 10.
10 out of 10.
all right, excellent, excellent. So that's the commutative. Excellent, very good. I'm glad that y'all are getting it. Math is easy. You don't have to make it hard. Now, so that's the commutative property, right? So that's 1 of 3. So remember we said that the topic really was 3 essential properties. So that's 1 down. Like they say, 2 more to go. So these, so is this anyone first time learning commutative property, or you've saw it before?
My first time.
First up.
First time.
Okay,
My first time too.
okay. All right, that's very interesting because this is one of the first things you're supposed to learn in math, right? This is one of the first things. You learn this in grade 7. They should give you it in grade 7. No, they should give you this in primary school. From primary school, you're supposed to learn commutative property, and we emphasize it in grade 7 and in high school again. But some persons just skip this because, I guess, because, I don't know, but these are very important properties. So we learn about the commutative property, essential mathematical properties. So section 1 was the commutative property. Then we're going to learn about another one. That might be our last one because that might take up all the time. The next one, I hope you're excited about the next one. Next one is interesting. It's also good and fun. Section 2. So section 2 is actually the associative property. The associative property. All right, so to associate means to do what? If I say I associate
Come
with you,
together.
come together. I like that. I like that definition. Okay, so to associate means to dwell, not dwell, but means to um means to group yourself with persons with whom you may share similar interests or pursuits. All right, in mathematics, the associative property states that the way we group terms when we multiply, when we add or subtract them does not matter because the result is the same no matter what. So the associative property is about grouping things. So the first property, commutative property, deals with switching things, switching them together, switching things around. But the associative property deals with grouping things around. All right. So it says that the way that we group terms when we add or multiply them, when we add or multiply them, does not matter because the result is the same no matter what. So symbolically, we can state this property in the following way. So we can write this rule in the following way. So we'd say the associative property for addition, and in general it is the following. So it's going to be, if we have A plus B plus C, it's going to be the same thing as A plus B plus C. What I really mean is, if we were to group, say, this one, and if we were to group the next one, it's still the same. So let me make that smaller so you can actually see what's happening. Good. So what actually did I do here? I grouped A and B, right? And then I add C. And then for the next one, I grouped B and C, and then I added A. All right? It's the same thing. So if I group A and B, then add C, is the same thing as me grouping A and B and C, then add an A. This is what we call the associative property for addition, or of addition. Really, of addition. And the associative property of multiplication, anyone could guess what it is? What do you think it is? Anyone want to give a guess what they think the associative property for multiplication is? How you think it's going to look?
I will want to guess.
Go ahead, try.
And multiplication, this is A plus bracket, B times C bracket.
Okay, so it's exactly the same thing as the first one, only thing we changed the sign. So it's A times B times C, and this one is going to be same thing, A times B and B times C. Okay, and this is associative property of multiplication. So the way that we group things when we multiply them doesn't matter. It's still the same. We still get the same result. Now we could show this by examples. So instructions. In each case, apply the associative property. Well, before I get the examples, let me not get the examples yet. Let me just show you that it works. So let's say we have so let's say we have the first way, Then we have the second way. Or we'd say the first grouping, and we call this one the second grouping. And the associative property. So let's get a nice design for this. So the first grouping, so let's say we have 2 plus 3 plus 4, right? So 2 plus 3 plus 4, 2 plus 3 is going to be 5 plus 4, and 5 plus 4 is going to give us 9, right? Now the second grouping, we're going to still have the 2 plus the 3 plus the 4, but this time we're going to group the 3 and the 4. Alright, so we'd have 2. 4 plus 3 is 7. So that's 2 plus 7. And that equals to 9. And so there we have it, that yes, the commutative property works, because in both cases we were able to get 9. So what happened here, we grouped the 2 and the 3. Okay, but here we grouped the 3 and the 4. Okay, and so when we group 2 and 3, we get 5. 5 plus 4 is 9. Here, when we group 3 and the 4, we get 7. 7 plus 2 is still 9. Excuse me. And so, yes, the commutative property works for that. So this is basically what the commutative property is saying. So let's do another one, but this time for multiplication. So if we do the same thing, let's say we have 5. Let's insert something, say. So we have 5 times 4 times 2. Good, so 5 times 4 is going to be 20. And 20 times 2, well, that's 40. And so in this case we get 40. Sorry, let me increase that still.
Excuse me, Mr. Isaac.
Go ahead.
I don't get
You don't get what?
first line.
I could
Because it
barely
ain't the first and the second grouping.
hear you. Say it again.
I said I don't get the first line because it ain't the same as the first and the second grouping.
Okay, so let's look at the first and second grouping, right? Let's look at for this one. For this one, we have 2 plus 3. That gives us 5, right? And if you add 4, that gives us 9. So in this case, 9 is the answer. So, but then if we do it again, still 2 plus 3 plus 4. But this time we add in, or this time we group in the 3 and the 4. We get 7. So 7 plus 2, which is 9. In both cases, we get 9. So here we get 9, and here we get 9. So that's why we say that the associative property works. Now for the second one, I am doing another example. This one is with multiplication. And I have 5 times 4 times 2. And we know that 5 times 4 is 20 times 2 is going to give us 40. Now if we do it again, that's going to be 5 times 4 times 2. But this time we're going to group the 4 and the 2. So we have 5 times 4 times 2 is going to be 8. And 5 times 8 is 40. So in both cases, we get 40. So here the grouping was this, and here the grouping was this. So we can say that yes, the associative property works for that. So, okay, now it's time for the examples. I think we're ready for the examples. So the instruction states to in each case, apply the associative property. Simplify the results. So simplify your results. So question number 1. So let's say we have 1. So bracket 1 plus 2 plus 3. Okay, so Jasmine, how would we apply the associative property? Jasmine, how do we apply the associative property here?
I'm supposed to add the 1 and 2.
Add the 1 and the 2. I mean, in terms of for this one, so let's group them different. So we're still gonna have the 1, still gonna have the 2, still gonna have the 3, but what we're gonna do different? Which numbers are we gonna group?
You wanna add B plus B?
Jasmine, what numbers we gonna group? Go ahead, Jasmine.
Pardon?
What numbers are we gonna group together? So in this case, we group the 1 and the 2. What are we gonna group in this case? Okay, I don't think she know. Sierra, help me out.
Okay, we're gonna group the 2 and the 3.
Yeah, we're gonna group the 2 and the 3. Good. All right, so if we were to do it, what is the result of 1, 2, 3? I mean, of 1 plus 2 plus 3. If you were to add them all up.
It'll be 6. 1 plus 5 equals 6.
Very good. 6. Very good. Okay, Deshaun, help me out with the next one. let's say we have 4 plus 5 plus 6, and let's say that we grouped this one together. How would we group the other side? How would we apply the associative property?
You would say 4
Mm-hmm.
plus open bracket 5 plus 6
Mm-hmm.
that equals 15.
15, very good.
See, I just had to calculate that in my head before I
Yeah.
do the answer.
Yeah. 6 and 4 is 10 plus 5 is 15. Okay. All right, Sierra. I mean, not Sierra, Deja. What if I do something like this? What if I say 2 plus 1 plus 4, and let's say I group these two first. How would I apply the associative property?
Well, the answer to that one is 5, 7, right? But then, what? How would that work for you?
Mm-hmm.
Could you possibly put 2 plus 1 in the bracket and then have 4 on the outside, or no?
Yes, that's exactly right. So you'd say 2 plus 1 plus 4. It gives us 7. So what I do is I started from this way. I started from this side and I moved to this side. So I did the 1 plus 4 first. And if I'm applying the associative property, I have to do the 2 plus 1 next. Okay. So we just switch in with which one we are grouping. So the answer is 7. Okay. So what if I have 7 plus 2 plus 1? This one is for Casey. What would my answer be?
Two.
2? Why you say 2? Go ahead, Casey. We still keep the same. Go ahead.
So, okay, 2.
Or I think it's better if we put 7 first, then 2, then 1. Okay, so what do we do from now?
Put the brackets.
Around which two numbers?
7 and 2.
But we already have the brackets around 2 and 1. Oh, you say 7 and 2. Very good. That's correct. Very good. Very good. Excellent. What's the answer for 7 plus 2 plus 1?
10.
10. Very good. All right, excellent. So now let's do multiplication. So if I say 5 times 5 times 2 times 1. Rashan, how would I do number 5?
2 times 1, 5, open brackets, 2 times 1, close brackets,
Very good. Very good.
equals 10.
Equals 10. Very good. Very good. Excellent. So this equals to 10. All right. Remember that this also works for letters as well. So if I have H plus R plus M, Jasmine, what would it be?
It'll be H times plus. That's a plus sign, right?
Mm-hmm.
Then R plus M.
Mm-hmm.
Plus.
Yes, R plus M close bracket. Very good. Excellent. And we can't simplify that. We have to leave it as such. Okay, good. All right, so those are the examples for that. So now my question is, does the associative property hold for subtraction? Okay. Does the associative property hold for subtraction? So that's the question. Does it work for subtraction? Any answers? What do you think? Think it works for subtraction? No? Anyone else? Anyone else? Do you think it works for subtraction?
I think it's maybe.
You think it's...
No, I don't think so.
I don't think so.
You don't think so? You sure? Just because...
No, because you chuckled just now. Hold on. I tried to to make sure one of them.
So you're saying, oh, well, it doesn't work for commutative property. It doesn't work. So it doesn't work for associative. You think so? You sure about that?
So like it's different.
You think it's different? Sierra, what you think? You're kind of quiet.
I think it works.
You think it works. Okay. She said you think it works, boy.
I don't think it does. I just tried one just now. Or maybe I just didn't do it right, but I just tried one and it didn't work.
That it didn't work. Show your example, right?
What I did was I put 5 take away 2 in a bracket, and then I just say take away 1. I just used one of those you had up there, and I got 3 take away 1, and I got 2, right? But then when I did it the opposite way, when I put 2 take away 1 in a bracket, take away 5,
yeah,
I got 4. So yeah,
so
I don't think it works.
you don't think it works, right? She said she don't think it works. All right, let's see. So let's determine if the commutative property, sorry, if the associative property works for subtraction. Now, if this property, if the associative property holds for subtraction, then that means that when we group terms one way, and then group them another way, when subtracting, we should get exactly the same answer. Okay. Now, if that's a very important word, if the associative property holds for subtraction, then that means that when we group terms one way and then group them the other way, and then group them another way, we should get exactly the same answer. So let's try. So we have the first grouping, second grouping, and then we have the associative property. So we could try 7 minus 3 minus 2. And then we could switch it around and we could say 7 minus 3 minus 2. But this time we have it over the 3 and the 2. So if we look carefully, 7 minus 3 is going to give us 4. And 4 minus 2 gives us 2. With this one, we get 7 minus 3 minus 2. 3 minus 2 is 1, so we get 7 minus 1, which is 6. So if we look at this, and this one we get the result of 2, and in this one we get the result of 6. And so
I don't get it.
you don't get it? Okay. Okay, so what we did, we subtract 7 minus 3, and 7 minus 3 gives us 4. After we get 4, we do 4 minus 2. 4 minus 2 is 2. Okay, and then when we go to the next one, we do 7 minus 3 minus 2, but first we do what's in brackets first. So 3 minus 2 is 1, and then 7 minus 1 is 6. So in this case we get 2, in the next case we get 6. And so here we get 2, here we get 6. And so the answers are different. So in this case we get 2, in the next case we get 6. So that means that it does not work. All right. Maybe that will be clearer. 7 minus 3 is 4. Minus 2. 4 minus 2 is 2. 3 minus 2 is 1. And 7 minus 1 is 6. So here we get 6. Here we get 2. Here we get 6. So the associative property doesn't work for this one. So clearly, the associative property does not work for subtraction. But the question is, does it work for division? So does the associative property hold for division? So let's determine if the associative property holds for division. Now, if the associative property works for division, then that means that when we group terms one way and then group them another way, of course that's when dividing, we should get exactly the same answer. So if we look carefully, here we have the first grouping. The next one we have the second grouping. And then finally we have the associative property. We could try 16 divided by let me, where's the division sign? Do I use the division sign? One moment, let me get the division sign. Wait, let's not use 16, let's see. Yeah, so let's do 16 divided by 4. So 16 divided by 4 is divided by 2. No. You have to do 60. Sorry, my bad. My apologies. So we have to do 16 divided by 4, close bracket, divided by 2. So 16 divided by 4 divided by 2. Now, for this one, we note that this is going to be equal to, what is 16 divided by 4? Anyone?
4.
4, very good. And what is 4 divided by 2?
2.
2, very good. Let me note that. The study division sign. Let me find a different one. So next we have 4 divided by 2. 4 divided by 2 is what? 2. Okay, so let's look at the same idea here. But this time, instead of grouping the 16 and the 4, we're going to group the 4 and the 2. So we have 16 divided by 4 divided by 2 is what?
8.
8. No, 4 divided by 2. 4 divided by 2.
I see you at my bad. What about it is 2?
2, yes. Which equals to 16 divided by 2. So that's 8. So in the first one, we get 2. In the second one, we get 8. And so that shows clearly that the commutative property, the associative property does not work for division. So it works for multiplication, it works for addition, but it doesn't work for division. So then that's that. So summary. So operations for the associative property. Basically, it's the same thing as the commutative property. It only works for addition and multiplication. Operation, associative. So for addition, multiplication, subtraction, and division. So yes, it does work for addition. Yes, it does work for multiplication. No, it doesn't work for division. I mean subtraction, and no, it doesn't work for division. Okay, so that's important to take note of. Okay, so that's a summary. Okay, now it's time for the questions, the practice. All right, so okay, so let's practice. So true or false. To associate means to substitute. The associative property is about grouping terms the associative property only works for addition when you are adding single digits. True or false? The associative property does not work for division. True or false? A, B, C equals A, B, C is the associative property for multiplication. Okay, so there are your questions. I'm gonna put the timer for 2 minutes, and you can do them. Circle true if its answer is true, circle false if the answer is false, and I'll see you on the other side. All right, so time is it's definitely up. All right.
Can I answer the first?
Okay, sure, no problem. Go ahead. So to associate means to substitute. What do you think?
20.
Say it again. Go ahead, Alton.
It's false.
Yeah, definitely. Um, Albernic, number 2. Albernic, number 2. Go ahead, Alton.
True.
To associate, the associative property is about grouping terms. Yes. That's true. Um, Number 3, Rashan. The associative property only works for addition when you are adding single digits. True or false?
False.
Yes, that's false. It always works for addition. Casey. Number 4, the associative property does not work for division.
True.
True, very good. Oh wow, it's 8:10. Okay, number 5, Jasmine. The associative property holds for subtraction.
Pardon.
Number 5. Does the associative property holds for subtraction?
That's false.
Yes, that's false. Okay, Sierra. Number 6.
That's true.
That's true. Very good. I'm glad that you saw that. Because even though I don't have the multiplication sign, that still means multiplication. So yes, that is true. Okay, so that's the answers for that. 6 out of 6, anyone?
Yes.
5 out of 6.
6 out of 6.
6 out of 6. Very good. That's excellent.
606.
That's great. That's very good. So we can wrap it up with that. So that's the end of math class. We're gonna move on to English class. I didn't realize it's 8:11 already. That's pretty long. Spend extra time on this. So, but we covered 2 rules. That's good. 2 properties really. The associative property and the commutative property. Very important properties. Yeah. All right, so let's look at, we began it yesterday. That was capitalization rules. And yesterday we only managed to be able to get through 3 of those capitalization rules. Before I open it up, anyone could remember the capitalization rules from yesterday? Anyone?
Capitalize the first letter in the first word in every sentence.
Very good. That's the first one that we saw. What was the next capitalization rule?
It's the different different I. Isn't it?
Yeah. Capitalize the pronoun I. Even if it's with even if it's with or I'll, still capitalize them. And the third one that we looked at yesterday was what? The third one. Deshaun. The third capitalization.
Capitalize the first letter of the first word in each stanza in a poem.
Not stanza.
Line.
Each line, yeah. Each line in a
Lines
poem.
of poetry.
So
Yeah.
where did I get stanza from?
You said stanza. I remember you said stanza last night, and I said lines, and then you said stanza, but it's stanza. I mean it's lines. So every line you capitalize. And most lines are poetry. So capitalize the first sentence in a word. Capitalize the pronoun I, and capitalize the first letter of the first word in most lines of poetry. Then we give a classic example. Roses are red, violets are blue. Everybody should know that. If you know one poem, you know roses are red, violets are blue. Am I right? That's at least one poem you should know. Okay, so the next one, the next capitalization rule that we're gonna go over. So we done those three. We're gonna continue on with the rest.
Excuse me, you have to head up for just continue.
You can put the date, like put the 7th, the 27th, the 22, but you don't have to head up again. Just continue from where we left off, but just put the date to let you know that, hey, this is something that we looked at multiple times. All right. So what we want to do is we want to capitalize the first word, the last word, and all important words in any title. Do not capitalize a, and, the, and, but, or, nor, or prepositions of 4 or few letters. Of 4 or few letters. Unless they are the first or last word of a title. So this is the 4th capitalization rule. You want to capitalize, you want to capitalize the first word, the last word, and all important words in a title. But don't capitalize a, and, the, and, but, or, nor, or prepositions that are less than 4 words, unless they are like the first or last word. Okay. So let's say
what about if but or what about if but or conjunctions like that? What if both if they're at the beginning of a sentence?
Yes, you could capitalize them. Now, remember, this is talking specifically about a title though. Okay? So these are talking specifically about when you're dealing with a title. Like the title of a book or, something like that. The title of a poem, the title of something, Once you're looking at a title, Um, we're looking at the title. Um, you have to capitalize the first and last word. Okay, so let's look at some examples. So let's say we're looking at a title. So examples. Let's say we're looking at the title of a book, and it is. So this is the title of a. This is the title of some sort, and it says The Little Prince. Now, The Little Prince has a title. So the question is, something in here is wrong, and the question is, what is it? Okay, so we know it's wrong. What do we have to change? Sierra, what do we have to change?
Oh, we have to change the first letter in all three of those words.
Very good. So they all have to be capital. So The Little Prince. Okay, this is gonna be the right way. And B. This one is Gone with the Wind, and we assume that this is a title. This is wrong. The question is, how do we fix it? Deja, how do we fix it?
We have to capitalize the first word.
So gone. What else?
Uh,
Uh,
I think we have to leave. Do we have to capitalize with?
um, you tell me. That's your question.
I don't know. I don't know. I think you should. I don't know.
Okay, is it the first or last letter? If it's, is it the first word or the last word?
Never mind, never mind. It's not. It's not. So just leave it lowercase.
Is it an important word?
I guess. Yeah, leave it lowercase.
Okay, very good. Lowercase. How about the?
I mean, I would leave it lowercase and then capitalize when probably.
Yeah. So those with and the and those stuff, they're not important, right? We're looking at like real words. So like gone, wind, prince, little, those stuff we worry about. Okay. So this is the right way. Don't doubt yourself, Deja. Don't be scared with your answers. All right, so let's say we're looking at another heading, and the heading is happy birthday. So say that's a title. It's wrong. What could we do to fix it, Deshaun?
Capital H
Capital
and
H.
capital B. Yeah.
Very good. Capital H and capital B. So happy birthday. This will be the right way. And then it's the fourth one. If we have so if we have ghost of the lagoon, I want Deja to do this one because she seemed a little confused. So go ahead, Deja. How would we do this? Which ones would be?
I'd capitalize G of ghosts. I'd leave of lowercase. I'd leave the lowercase and probably capitalize lagoon, the L in lagoon.
Very good. So ghost of the lagoon. Okay, that would be the right. Wait. So you think you're getting the hang of it, Deja?
I think so.
Okay. So if it's a preposition that is less than 4 letters or 4 letters or less than 4 letters, then we do not capitalize it. So stuff like as, and it, and to, and by, and at, and with, and over, and for, on, to. Behind is a lot. So Behind. Yeah, that's.
So you have to capitalize that, right?
Yeah. So per less out. Those things we don't capitalize. So next thing that we want to do, or the fifth capitalization rule, is we want to capitalize people's name and their initials. Right? So interestingly enough, if you have someone name, right, you have to capitalize it. The first letter the first letter and the last letter of their first and last name. Sorry, the first letter of their first name and the first letter of their last name. So let me include that first letter of first name and first letter of their last name. And of course their initials. You want to capitalize them. So for example, if we have George W, sorry, George, oh my goodness, they like George, we can't have George, good, George W Bush, what's wrong about that? Jasmine, what's wrong about that?
The G in George supposed to be
G and J.
capital.
What else? Capital.
The W.
The W, very good. What else?
And the B in Bush.
And the B in Bush. Okay, so this is the right way. This is the wrong way. So, who was the first Bahamian Governor General of the Bahamas? The first Bahamian Governor General of the Bahamas.
You said it was the first Bahamian of Bahamas.
The first Bahamian Governor General.
Which was this?
Bahamian. He was the
Samara Butler.
Milo Butler. Very good. So Milo B. Butler was the first Bahamian Governor General. Woodes Rogers was the first Royal Governor General of the Bahamas, but not Bahamian. Woodes Rogers wasn't Bahamian. So Dylan, how can we correct B?
Capitalize the M in Milo.
Yeah.
Capitalize the B.
Put a dot.
Yes,
Yeah,
sir.
you need a dot
And
there.
capitalize the B in Butler.
Very good. So this is the right way that we could do it. So, who was the first female Governor General of Bahamas?
Dame Ivy Dumont.
Mm-hmm. So Dame Ivy Dumont. She was the first female one. The current one that we have now is also a female. You know who that is?
We have a female now? I
Yeah,
thought she.
Yeah, we have a
Victor.
female. Well, unless they change it. The last time I know.
I thought it was C.A. Smith, Cornelius A. Smith.
Oh, they changed it. They changed it from Miss Penley?
Long time.
Okay. Well, I outdated. From 2019, I see. All right.
C.A. Smith.
Okay. Dame Ivy Dumont. Yeah, so it was Dame Ivy Dumont. She was the first female. And after her came Paul Adderley, but he wasn't used like acting one. And then in my day, it was Mr. Hanna, Arthur Hanna, and Arthur Folks. And then Miss Penland came along, and I don't know who the new one is now. Would you say his name is?
Cornelius A. Smith.
Cornelius. Yeah, Cornelius. Okay. Yeah, since 2019 when Dame Ivy Dumont. I'm sorry, when what's her name? Miss Penland left. Okay, you're right. Yeah, I outdated, but yeah. Mr. Cornelius. That's the same man from Religious, right? I don't know if y'all remember the story of Cornelius.
Pardon?
Cornelius. You ever did the story of Cornelius in RK?
No, so I've never heard that.
Yeah, right. You can't be serious. Cornelius.
You asked me if I heard the story of Cornelius.
Yeah, Cornelius.
You mean in the Bible?
Yeah.
Oh, of course.
Okay, I was wondering. Yeah. Cornelius, that's with Paul. Okay, so how do we fix this? Sierra.
Okay. D and Dame, I and Ivy, and D and Dumont.
Very good. Very good. So, right. So you always capitalize people's name, their initials, and the first letter. So that means the first letter of their first name, the first letter of their last name, and any initials. We capitalize them. So just keep those in mind. George Bush, nothing to do with the Bahamas. Just United States what?
Who's the president?
Yeah, president. Who's the current president of the United States now?
Sure. I think that's his name, Joe Biden.
Yeah, Joe Biden. And before him was Trump.
Donald Trump.
Donald Trump.
No one could forget him.
No one could forget him, for sure. For sure. Oh, boy, that was interesting. That was a funny one. Oh my goodness. Okay, so, all right, so the next one that we want to do is the next capitalization rule is we want to capitalize days, months, holidays, and special days. So, Deja, I saw you didn't do this in your little paragraph on independence. what you're doing. It wasn't on independence, it was on your vacation in the Bahamas or something like that. And then you mentioned independence, but you didn't capitalize it. But you want to capitalize important days. So capitalize days, months, holidays, and special days. So, examples. So, for example, if we have Tuesday, see, they don't even want me to write it without capitalizing it. So Tuesday, it must be capitalized. Because it's a day of a month. So because of the day of it's a day of the week. And then July. Interesting, because we are in the month of July. Realize that only a few more days until August, right? When the yard school open, Deja? Deja, when yard school open?
I think they said August 29th.
Wow. 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 Anybody else school open in August?
Is that early?
Me.
Jasmine, what school do you go to?
Billy.
I could barely hear you. Say it again.
Billy.
R.M. Bailey, yard school open in August?
Yes, sir.
Wow. I thought government school open in September. Yeah. In my day, school open in August is unheard of. It's always September. Because I went to government school my whole life, so. Yeah, we usually open in September. And we only have 2 semesters, fall and spring. Not falls, Easter and summer, whatever them other schools have. We only have 2 semesters. Fall and spring, 2 GPAs.
I have 3.
Say it again.
We normally have 3.
Boy, who are you?
Not necessarily.
That means you have 3 exams. Oh boy.
Oh no. From grade 10, you only have 2 exams.
Oh, you only have 2
And then
exams.
the middle term is just like you just get graded based on your classwork and stuff.
Oh, you just trying. Oh, okay. Well, that's good. So how do we correct this? Christmas Eve. How do we correct it?
Anybody could answer?
Yeah, anyone could answer.
Okay, we will capitalize the C in Christmas.
Very good. And the E and Eve?
No.
Yes, we also capitalize E and Eve. So Christmas Eve. Christmas Eve. It's in the air, people. It's in the air already. All right, so good. So you capitalize days, months, and holidays and special days. You capitalize people's name, the initials. You capitalize for books and titles. You capitalize the important words, and you avoid those prepositions. Okay, so with that, we're gonna close here. I'm gonna let you all go free. And we still have some more capitalization rules to go, but we'll end here. And then tomorrow, we're gonna continue our journey with the capitalization rules, and we have to look at another property. So we did associative, we did commutative. There's one other property that we have to do, and that'll be it for the properties. And we have to also continue with the capitalization rules. Nonetheless, thank you so much for your time. Have a wonderful evening. Please send the notes. Please send the notes. I don't want to have to run after no one for notes. And I'll see you on
Oh, you don't have
tomorrow.
to worry about that. I got you with notes.
Yeah, I noticed. I noticed. All right. Have a good night.
Good night.
Yes, sir.